Hey guys, I wanted to take a quick second. I know it's a little hard to see, but I wanted to do a quick review for our quiz this week. Let's go ahead and share screen, get scale factor. We're talking about scale factor, and we're talking about triangles. So we're going to go ahead and remember this goes over for this past week, so the week of 31st. Don't forget to check your email, consistently check your schedule, check your grades. Scroll down here and go ahead and get started. So remember, this goes over in conjunction with the 2.01 quiz. Let's go here. And don't forget, a lot of your teachers are traveling this week, hence why I'm recording this from the airport. So for those of you that, sorry, I'm trying to find the best spot in the line. Here we go. All right, so for those of you who are going to ask me for this review video so you can get extra attempts in your quiz, I'm going to be asking you questions about the video to make sure that you watched it. And one of those will be where I recorded it. So definitely be on the lookout for clues in this video. So we're talking about scale factor. Scale factor is the number by which all components of an object are multiplied in order to create a proportional enlargement or reduction. So it can make an image larger or it can make it smaller. In our example here, and this is something that we talked a lot about in class, if you were going from this figure A to this figure B, it would be called an enlargement. But if they were flipped and you were going from B to A, it would obviously be a reduction because it would be a smaller image. Now, to be an enlargement and go from A to B, you're multiplying it by 2. How do we know that? We find the corresponding sides. So this side, we'll put 2 markers here. Sorry, my writing, because we know that these 2 sides correspond. Those are the same sides, but on a different object. So what we do is we take the second object. We always take the second object right here and use that as your numerator. And then you take the first object and you use that. I'm sorry. There we go. Numerator, denominator, divide. And we would get 2, and that's how we know that our scale factor, if you're going from object A to object B, is 2. And I have no idea when my pencil went away. So that's how we got the same thing. Now, to do the reverse, we got right here, if we were going from object B to object A, so if they were in reverse order and they were asking for the scale factor, we would be dividing 5 over 10, which is how you would get 1/2. Okay, so that's scale factor. I want to go over this slide right here. I have to delete my drawings. I apologize. So in this one, you can write scale factor right here. You can write it as a fraction, or you can use a colon. Here's another example of scale factor. We're going from the smaller object to the larger object. So obviously, if you're going smaller to larger, you're increasing. Okay, it's not a reduction because you're increasing. Important things to remember, corresponding angles. We touched on that a little bit when I did the 2 line markers. So we would say that angle A corresponds with this X right here. Different shape, same spot on the shape. The same as you could say with JK corresponds with RS. Another way to say it is KJ corresponds with SR. Okay, so you can go with the whole entire shape and find the corresponding sides or angles with the other shape that it's compared to. Right here, another great example of finding corresponding sides and then finding the scale factor. Remember, it's the second shape over the first shape. So they took QR over LM. Why did they take QR over LM? Because QR is the second shape. Second shape over first shape. Excuse me, corresponding sides again. Great slide on corresponding sides, just what we went over. Jump down here. I love this visual, second image over the first image. Trying to get down to triangles. Triangles. Triangles are super fun.
Dr. Key, welcome aboard.
Right,
for Phoenix,
so,
flight 1402.
You hear the noise? Another key fact in this video is I'm in an airport. So you're going to be asked a question about where Mrs. Jones filmed this, and it was in an airport. Sorry, I'm trying to find the triangle. Here we go, triangle signs. Right here, equilateral triangle has 3 equal sides. See how each one of these has 2 lines
Group 1, you're
indicating
welcome aboard.
that those sides
This
are the
particular
same.
gate reader, it's face up.
Isosceles triangle has 2 equal sides. Scaling, no equal
Barcode in the
sides.
red light.
If you're classifying a
This
triangle
side.
by sides, 3 angles less than 90 is what makes it acute. 1 right angle makes it a right triangle, and then an obtuse triangle has 1 angle greater than 90. Right here, acute triangle, this is the example they gave us. Remember, we said acute triangle has angles that are less than 90. So if we look at this acute triangle, every single one of these is less than 90. Right triangle, love right triangles. You see how it has that little, we called it a chair last year, a little chair in the corner. Okay, so it has that little square, and that indicates it is a right triangle because that little symbol indicates that that angle is equal to 90 degrees. Obtuse triangle. Obtuse triangle has 1 angle
Groups
greater than
1,
90
2, and 3
degrees.
are welcome aboard for Phoenix.
Since you love this, love being in the airport. Okay, so right here, 1 angle is greater than 90 degrees. So 120 is greater than 90. 110 is greater than 90. 100 is greater than 90. So when we look at these right here, we would say it's an equilateral triangle because these 3 sides are all equal. When we're going here, you see how we have 2 that are equal? So it would be an isosceles. Let's go down here and find, I want to make sure you guys get a chance to
Group
look
4.
at this. So the corresponding IXL skill that you're going to want to make sure you complete before you do the video is 5RX. If you have any questions, don't hesitate to reach out.